What on earth has light got to do with the energy content of something? It would at first seem that light has a particularly deep meaning in the universe. However, this appearance is illusory, because it turns out that c is not primarily the speed of light. It actually measures a much more basic geometric property of the universe, and the physics of light are such that the speed of light happens to equal this speed. It's a bit like saying that the speed of the salmon giri cart that you watch as you sit in a restaurant is the same as the speed of the sushi train. The speed of the salmon giri cart is what it is only by dint of the salmon giri's particular relationship with the sushi train itself. Light is just one way this particular property of the universe manifests itself. Albert Einstein is credited with the creation of the Special Theory of Relativity in his famous 1905 paper, Zur elektrodynamik bewegter Körper. But he was far from alone in pondering the curious results of the famous Michelson-Morley experiment that showed that velocities do not add to the velocity of light c in the intuitive Galilean way that low-speed velocities do. Nor was he alone or even the first in explaining them by assuming, as he did, that Maxwell's equations, the theory of light propagation, must transform between frames of reference in relative motion in a way such that their form does not change, thus keeping the speed of light constant. All of these things had been done by both Hendrik Lorentz and Henri Poincaré. In Maxwell's theory, c is defined in terms of fundamental constants from electrostatics and magnetostatics. So, if the form of the Maxwell's equations does not vary, then neither does the speed of light. Lorentz and Poincaré stopped short on saying that the time coordinate t was the actual time that clocks count in different reference frames. They conceived of concepts of effective time to explain their results. It's actually hard to know what they were thinking exactly. As for the relativity of Galileo, as described in my last article, their relativity was sound, but they lacked the boldness to confront the idea that clock-measured time changes between frames in relative motion fully head-on. Einstein seems to be the first to fully embrace this radical conception of time, that the clocks of different observers in relative motion really do tick at different rates, and to state it publicly in academic discourse. More particularly, Galileo's relativity leads to the whole family of Lorentz transformations, parameterized by an unknown constant c. Ignatowski's theory thus gives the correct form of the Lorentz transformation, but the parameter c must be determined by experiment. If one, as Galileo did, assumed too much and thought that time would be measured in all frames in the same way, then we recover the limit of the Lorentz transformation for infinite c. The Michelson-Morley experiment can then be taken as the experiment that found the unknown constant c in Ignatowski's theory. Maxwell's equations are then shown to keep their form between frames in relative motion as a result of Ignatowski's theory and the implication of the Michelson-Morley experiment that experimentally fixed the value of c. But what's even more impressive is that, when astrophysicists calculated how long it took for light to emerge from the smothering fog of debris from the merger of two neutron stars, they could account for more than 1.6 seconds of that delay, leaving only about a tenth of a second unaccounted for, meaning a result confirmed to within 1 part in 10 to the power of 17. Since general relativity predicts that gravitational waves propagate at the speed c, there was probably not one serious physicist in the world who was surprised by the result. What do you think of speed of light? Let us know in the comments. Thank you so much for watching.